Good morning, sir. We would like to have a small audio and video check before we proceed.
Hello, good morning.
Thank you, sir. We can hear you.
Could you listen to me?
Yes, sir.
Okay. Anything from my side before I start?
So I just wanted to check, would you be sharing the slides or should we be sharing it?
I'll do that.
All right, sir. So shall we begin the session?
Yeah, I'm ready.
All right, sir.
Shall I first check with my slide share? Shall
Yes,
I check my slide?
Yes, sir. Go ahead.
Okay. Is it visible?
Yes, sir.
Yes, sir, it is visible.
Okay. So I'm ready. If you like, I can start.
A very good morning to one and all present here, esteemed dignitaries, delegates, faculty members, and students. We welcome you all to the second day of Insight 2023, the 8th National Conference on Intelligence in Animals, Humans, and Machines, organized by our very own psychology department of Christu Jayanti College in collaboration with the National Institute of Advanced Studies, Bangalore. Esteemed guests, it is with great pleasure that I announce the presence of our first keynote speaker for the day, Dr. Manas K. Mondal of IIT Kharagpur. He was formerly Director General of Life Sciences in DRDO, Director of DIPR, Defense Institute of Psychological Research, for our third plenary session. May I now request Ms. Shruti K. Mukashi to introduce and invite respected Dr. Mondal for the session.
A very warm morning to all the dignitaries, delegates, faculties, and my dear fellow students. It is said that gaining knowledge from an experienced person goes way beyond the insight one gains from books. On that note, for the third session of the two-day conference, I take the privilege to welcome you, our esteemed guest, Dr. Manush K. Mondal. Dr. Montol is a distinguished visiting professor at the Indian Institute of Technology, Kharagpur, and adjunct professor at the National Institute of Advanced Studies, NIAS, Bangalore, and Allahabad University, and is an emeritus research professor at Rashtriya Raksha University, India. Formerly a distinguished scientist and Director General of Life Sciences at Defense Research and Development Organization, DRDO, Dr. Montol specializes in the area of neuropsychology and cognitive sciences. Dr. Montol has to his credit 14 books and over 100 research papers in international journals of high repute with 7,000 plus international citations of research work. Sir was elected as the Fellow of National Academy of Psychology in India 2012, and for his contribution to psychological science, he was awarded the Technology Leadership Award by the then Defense Minister of India, Shri Manohar Parrikar, in the year 2016, and the Scientist of the Year Award in 2006 by Dr. Manmohan Singh. This session will be moderated by Reverend Father Emmanuel, TJ, Director of Christianity College of Law and Faculty Department of Psychology. Honorable Sir and Father Emmanuel, it is of an immense honor to extend a warm welcome today, and I invite you, Dr. Professor Manoj, to enlighten us with your knowledge in intelligence, behavioral science, behavioral, neuroscientific, and computational approaches. May I now humbly request Dr. Manoj to take over the session. Thank you.
Okay. First of all, I would like to ensure whether I am clearly audible to audience or not. Just if it is. Am I audible clearly?
Yes, sir, you're audible.
Okay. So very good morning, and thank you so much for inviting me for this very good and prestigious conference on human intelligence. Honestly speaking, I was very keen to come in person and do the needful. Unfortunately, we have been at IIT at the fag end of our semester. Therefore, it was not really possible for me to move out, and I decided in turn to talk to you online. So my apologies. But let me also tell you, it's a pleasure and privilege to be amongst you and in front of a larger band of students and the faculties who are in the discipline. It's a rare opportunity for me to speaking what is typically psychologically very relevant that we call human intelligence. Well, before I actually begin, let me tell you what is that I'm going to do. Certainly, I'm not going to talk to you what is there in the book, because we all have been reading books, we understand human intelligence. My effort to talking to all of you would really be letting you know what is happening all around in the field of research and human intelligence. Now, I'm not going to talk about the details of research that are being undertaken, but for the benefit of the students, it's very important to understand why human intelligence as a construct must come out of the book and should be relevant for sciences which are beyond behavioral science. So I decided to talk about the brain sciences as well, how human intelligence is relevant to brain sciences, which I call neuroscientific sciences, and as well as computational approaches, which is basically artificial intelligence. So these days we have been talking about artificial intelligence, human intelligence. I mean, when we talk about human intelligence, we really think in terms of behavioral sciences and neurosciences. But beyond that, of course, we are also thinking about how the human intelligence can actually be digitized and the input can be inserted or accommodated in a robot. So I'll be talking about all these, but let us first tell you what I'm going to talk in further detail. First of all, for the benefit of the students, I would first like to revisit the concept of human intelligence, how do we understand about intelligence for the last 100 years? Not about history, just about a couple of minutes I'll be spending on that. Then I would like to talk to you about how intelligence and cognition are related. I mean, in a classical book of human psychology, we always get a chapter of intelligence. But in recent books on human psychology, we find more and more effort in the area of cognition in order to understand intelligence. So it's very important to tell you that how intelligence and cognition are related to each other. Then I will talk to you about what are the different approaches to understand human intelligence, some traditional approaches, and some cognitive approaches which are recent trends. Then, of course, if we have to understand cognition in great detail, we also need to understand the research methods, which is beyond the classroom. We need to understand it. If any one of you are interested to take it forward in your next career, you should also understand what are the major paradigms which are available for doing research. Then, of course, I'll come out of the traditional book of psychology and will talk to you about cognition and brain sciences, which is the neuroscientific approaches to understanding human intelligence and cognition. And finally, I'll talk about how engineers and the technologists are making use of cognition in developing artificial intelligence and why we are falling apart. I mean, in the sense that the concept of intelligence started with behavioral sciences, but how it is actually been taken over by engineers and brain scientists in order to understand the factors, in order to understand the construct in great detail and make use of it in a translational manner. So, sorry. So my whole approach of talking to you would be twofold. One would be the transdisciplinary approach to understanding human intelligence and the translational approach. Let me repeat. The transdisciplinary approach is an approach where we do not talk about human intelligence with reference to a particular discipline. We actually talk about cross-sectional disciplines, which is much more than interdisciplinarity and multidisciplinarity, which I call is as transdisciplinarity. Why? Cognitive science is a more transdisciplinary phenomenon. And then we have to also understand why human intelligence are now being utilized in developing machines, in understanding brain disease, in actually doing some prognosis for brain damage, dementia, Alzheimer's, and so on and so forth. Therefore, my effort would not be restricted towards understanding human intelligence, what is there in the book. I would like to slightly go beyond. I'll take around 40 minutes from now on. And then, of course, if there is a query, I'll let you know. Finally, I'll talk about a SWOT analysis of the kind of effort we are making to understand human intelligence. SWOT analysis is strength, weakness, opportunities, and threat. That kind of analysis we are going to do at the end of it. I have got 15 slides. I'll take 40 minutes, I repeat, and thereafter I'll take up any question that you may have. So if we go for the book of traditional book of human psychology, we'll understand that human psychology says that intelligence is the ability to deal with abstract concepts. Like Louis Terman in 1920s actually developed this definition of it. And he thought that someone who can deal with abstract concept is basically an intelligent person. But then after some time, the person came who is known to all of us in terms of the history and his contribution to psychology is Thorndike, Edward Thorndike. Thorndike differed from actually Terman. He says that our ability to learn from experience should be called as intelligence. So the two people 100 years back from now actually differed on this concept. But from 1950s onward, the understanding of intelligence has started changing. Researchers started believing that intelligence has a fundamental function. And the fundamental function is to adapt with the environment. And when we try to adapt with the environment, it just can't be ability to deal with abstract concepts and the ability to learn from experience. It must be much beyond. So our ability to understand the context and the content and then accordingly adapt with the environment is actually something which should be considered as the definitional outpost for the concept called intelligence. So with this note, I'll try to tell you why the cognition and intelligence are to be understood initially separately and then in combination. Let me tell you that, as I said, that in the recent years, not really recent years, in the past several decades, the concept of intelligence has started, giving us the idea of adaptation. People started believing that simple intelligence will not be able to help us adapt. We must have the ability to perceive, attend, memorize, learn, problem solving capability, and then of course intelligence, and then of course emotion. Because for adaptation, we require everything. So we know that sensation is acceptance of energy. And when energy is interpreted, it becomes perception. But perception and cognition are two different things. Because perception is something what we see, but cognition is something what we see outside and how it is represented inside are two different things. How it is represented inside depends upon our attention, depends upon our capability to memorize, depends upon our ability to learn, how we solve problems, and then in a combination of all these, we actually understand what intelligence is all about. So if you put all these things together in a profile, we'll find adaptation. And we don't stop there in intelligence. Today, people talk about emotional intelligence as well, because people say that emotion has a priority over cognition, that is intelligence. There are theorists who say that our emotion has come first, intelligence has come later. But some people say that no, our ability to reason and intelligence has come first and our emotion has come later. The two sorts of theories, Richard S. Lazarus says that there is always a priority of intelligence or reasoning over emotion. But there are psychologists who says that we evolved and survived with emotion. And those two emotions are fight and flight. So we do not actually fight or flee with the dreadful situation with our intelligence. We first develop that emotion, elicit our reflexes, and then we judge the situation whether we should face there or again or not. So this is the difference between intelligence, which I call as a subset of cognition. Those who are having confusion between intelligence and cognition, they should realize that intelligence is a subset of cognition. When we talk about cognition, it is about how we register information, how information is represented, how information is processed and transformed, and how information is retrieved. The whole process is called cognition. And in that process, right from sensation to emotion, every step needs to be followed. Now, to understand human intelligence, actually, we have got four models. Now, of course, I'll not go for the animal model, but basically, I'll be talking about four models which are available to understand human intelligence. One model is, of course, psychometric, that is, test of performance-based measurement. And we all know psychometry is based on certain performance of the test. But when cognitive psychology came up, they say that to understand intelligence, we should not only think about the taste of performance or the outcome. We must understand the process. So those who are students of psychology, they must also understand that what is the difference between a test and an experiment. A test is developed in order to see the difference between two individuals. But an experiment is done in order to see what are the commonalities and similarities amongst the individuals. They're just opposite to each other. Therefore, the process is studied, the universal process, the generalizable process is studied more by experience. And the experiment is the hallmark of cognitive psychology. While the psychometric tradition suggests that your ability to perform certain difficult tasks will actually help you understand how much IQ or intelligence quotient you have. We have a fourth paradigm, which is the brain sciences paradigm. Brain sciences paradigm says that, well, we perceive certain things, but then we register it, then we represent it in our brain, then we transform it with our past experience, and the whole transformation has got a neural basis. Since there is a neural basis, there is a neural fire with every time we learn something. We should understand human intelligence from the point of view of brain sciences. But then we have a fourth paradigm as well, which is called artificial intelligence. Artificial intelligence suggests that whatever capabilities we have, let us try to learn all those capabilities in a variety of models and then digitize them. So digitization of the capabilities of in terms of human intelligence is basically done through computational model. We'll talk about all those one at a time. First, we will try to understand the psychometric paradigms, which is already there in the book. But for the sake of some kind of continuity in our thought process, I'll first talk about the psychometric paradigms. As I said, the psychometric paradigm started in sometime in 1905 with Alfred Binet, and a lot of researchers have started understanding the intelligence in terms of the certain factor analytical theory, which is called intelligence as a composite of abilities measured by certain forms of mental tests. Now, the first theory of intelligence that we understand is by Spearman. And Spearman's general factor theory suggests that we all know it, but as I said, for the continuity of our thought process, we'll just mention about it. Spearman says that we have a G factor, which is like a general processor, and then we have got certain specific factors. And the understanding of factor is done through factor analysis. Those who are in statistics will also know how factor analysis is done and how orthogonality between the factors are understood and how positive manifold is tested through statistical procedures. Now, Spearman was a statistician, and based on the capabilities through certain forms of test, he came up with two major factors. That's why it is called two-factor theory. One factor theory is a general factor, other factor theory is called a specific factor. Then come the theory by Thurston. He says, no, we do not have a general factor. We have got 7 specific factors. He talked about 7 specific factors, and he identified 7 factors which are orthogonal to each other based on test performance. And I'll not go into detail of it because these are something which are already available in the book. But then came the theory by R.B. Cattle, who says that, well, the G factor, the general factor, is a valid factor, but there are 2 general factors. One is a crystal factor, other is a fluid factor. He says that crystal intelligence is based on your capability to utilize your experience, past experience. If you have already learned something, and if you are capable of retrieving that, we'll call it as crystal intelligence. But fluid intelligence, what Cattle said, that is something where you can actually bring no knowledge to new knowledge, something you have never faced, but now you can solve it. So your processing speed, your perceptual organization is everything comes under your fluid intelligence. Crystal intelligence, of course, are like something verbal comprehension, working memory, that is memory which you would be using in a day-to-day affair. But then came the theory by Gordon and Cato, where they proposed about a hierarchical theory. They said that the G factor probably are three G factors, three domains. And one is a general factor, that is general ability variance in G. One is a broad ability, and one is a specific ability. Now, these are the, theories, which of course I'm not going to talk to you in great detail. Now, the Gordon and Cattell said that they are hierarchically organized. Now, in domain one, that is the general ability, you have got a general processing capability. But when it comes to broad capabilities, then you have got three domains. Domain one, which is crystal intelligence, domain two, which is fluid intelligence, and domain three, where your performance in specific test can actually be measured and your specific challenge can be deciphered. So they are all hierarchically arranged, this domain one, domain two, and domain three. So general ability, broad ability, and specific. These are the psychometric paradigms we have, which is based on test performance and statistically derived through factor analysis by testing whether these factors are orthogonal to each other, and they can be recreated in a graphical space called positive manifold. Now we'll move to the cognitive factors. Now, when we talk about the cognitive factors are actually paradigms where I said that it is something beyond intelligence and intelligence in terms of individual difference. Cronbach, I'm sure you all know about Cronbach alpha. He is also a statistician. He says that it is unfair to understand intelligence only in terms of individual difference. There are several commonalities of it. So the generality of human intelligence must also to be understood through cognitive phenomena. So he said about the information, his theory is about information processing approach, that how information is registered, how information is processed, and how information is retrieved. So he proposed about experimental approach as well as a test approach through individual difference. So cognitive theories evolved out of these paradigms to understand human intelligence. But then there are certain varieties of cognitive theories as well. One such variety is called cognitive contextual theories. Cognitive contextual theories suggest that the cognition doesn't take place in isolation. Cognition takes place in reference to certain context. The interaction of cognition and the context actually give rise to your emotion, give rise to your intelligence. So Gardner came up with multiple intelligence. He says that, well, there may be cultural intelligence, there may be biological intelligence, there may be musical intelligence, there may be visual-spatial intelligence. He talked about multiple intelligence, which has got a reference to certain context. But then Sternberg said that, well, the intelligence has to have three components, which is internal, external, and experience. He talked about a triarchic theory, and in this triarchic theory, we understand intelligence in three forms. One is analytical, creative, and practical. So by analytical, he says internal. By creative, he said external world. And by practical, he says experience. He says his theory is therefore called triarchic theory. So multiple concepts are being introduced in the cognitive theories to understand human intelligence. He says that the analytical concept capabilities is an internal capability. Your ability to adapt in unique situation is your capability which is coming from the external world. And your ability to utilize what has been found in terms of your internal and external world is the experience. And your capability to utilize your experience in day-to-day affairs is called practical intelligence. Therefore, the concept of Sternberg's triarchic theory has come up, and that is considered to be a very broad-based understanding of human intelligence. But then, of course, has come the theory of cognitive developmental theories by Piaget. Piaget says that this development takes place because he has a developmental perspective that how this cognition develops, at what point of time the intelligence comes up. He says that the cognitive development takes place via intermittent past. And we all must be reading in our books on cognitive development in terms of sensory motor stages, pre-operational stages, concrete operational stages, and formal operational stages. His basic concept is in intelligence is assimilation and accommodation. That how new knowledge is fit into the old knowledge, new knowledge is fit into the old knowledge, and how such knowledge is accommodated in our experiences. So these are the psychometric paradigms and the cognitive paradigms of intelligence. Now let us try to understand the cognitive science as such. Now, from now on, what we are going to talk to you is basically not about what is written there in the book traditionally. I'll be talking about the transdisciplinarity and the translational aspects of cognitive science. Now, cognitive science is a science that investigates the representation and processing of information. As I said, the cognition involves how we register information, how we process information, and how we retrieve information. So let us first try to understand this information processing model. Like, as I said, in the Cronbach's theory, that information processing approach is the fundamental process to understanding human intelligence. So it has been now been understood that information processing actually depends on internal representation. What we see at outside and what it is represented in my brain are two different things. So perception and internal representation are two different. Therefore, we must understand perception differently and internal representation differently. When something is represented internally, then they undergo transformation. Why do they undergo information? Because I have already seen or I may not have seen something. Therefore, the moment this input, represented input, is inside my brain, it is transformed into a different kind of perception. So that transformation takes place. When it takes place at a higher center of the brain, it becomes it develops a neural basis. So we call it as neurocognitive neuroscience. So brain comes into the picture because the moment we see something, there is a neural fire, and the moment there is a neural fire, there is depletion of oxygen, and the moment there is depletion of oxygen, there are a whole lot of changes that take place in the brain, and the perception and representation and transformation take place simultaneously to give you a percept of a particular object that you have initially seen in the outside world. But then now the problem comes up, not really a problem. The engineers, the technologists have understood that such brain functions can actually be simulated in computational terms. So it becomes part of the artificial intelligence as well. So you understand today that what we started in psychology as a psychometric approach of understanding human intelligence later on become cognitive science, and then we elaborated cognitive science in terms of information processing approach. Then we understand that such information takes place with some kind of representation and transformation in the brain. So brain sciences become involved in the whole process. And from brain sciences, the engineers and computational scientists, they have started digitizing our capabilities. And today they actually create a robot, which is equivalent to artificial intelligence. We'll talk about it. So the concept of transdisciplinarity, I would like to emphasize here that when we talk about only a particular discipline like psychological discipline, we'll call it disciplinary science. When it becomes multidisciplinarity, then we talk about two different sciences. Suppose psychological sciences and brain sciences. They actually collaborate with their finding. But when we talk something called interdisciplinarity, they not only actually collaborate with their finding, they also actually collaborate in their methodologies. So when they collaborate in their methodologies, it becomes interdisciplinary. But when it becomes a altogether new method to understand a science, it becomes transdisciplinary. So for the benefit of those who are not familiar with these concepts, let me tell you, cognitive science is a transdisciplinary subject. Why it is transdisciplinary subject? Because it has emerged from 7 different disciplines, right from philosophy of mind, how the mind is structured, to linguistics, that is every thought process has a language. We cannot think with a language. So if cognition takes place, it must be having a language. So language comes into picture. Then comes anthropology or cultural anthropology, because they say cognition takes place because cognition takes place in a given culture, and every culture has a logical rule. And if that rules needs to be understood and cognition is to be understood under a cultural context, we must also have some contribution from anthropology. So anthropological science came into picture. Then comes neuroscience. As I said, every cognitive process has got a neural basis because the transformation in the brain and through several activations in the brain takes place at the higher centers of the brain. So neurosciences has come into picture. And then of course has come artificial intelligence, the computational science. They say that every piece of capability, which we call so-called human intelligence, can actually be digitized. Therefore, the computational science has come up. And of course, the whole cognitive science has started with human intelligence. Therefore, psychology is already there. So now you understand today, when we talk about transdisciplinarity, we really do not talk about multidisciplinarity. We really do not talk about interdisciplinarity. Cognitive science has developed its own methodologies. Therefore, when it is problem focused, when a particular science is developing its own methodology, it becomes transdisciplinary in nature. So human intelligence, when it is elevated to cognitive science, these components must be understood at a particular point of time. Now let us try to understand what are the critical issues here. Because in the last slide, as I said, that, well, there are brain processes involved in cognition, and there are also computational terms we can try to understand the human capability. Now, these capabilities are understood at a very, very rudimentary level, at a very, very micro level. In brain sciences, we try to understand at a neuronal level. And in computational sciences, we try to understand in terms of a function with a digital code of 1 or 0. Now, the question is that human intelligence, can this be understood at a micro level? What is the concept coming up? So the understanding of human behavior or human intelligence has got 2 approaches. If human intelligence is considered a human behavior, we can understand at a macro level, we can understand at a micro level. We, the social scientists, view that the biological sciences or computational sciences are useless in reductionism. Because by understanding how a particular neuron behaves or how a particular function is to be digitized 1 or 0, we cannot understand the whole of human behavior. But the computational scientists and biological scientists believe that social science is nothing but a history of human experience. You can never understand cause-effect relationship in experimental procedure to understand what is the general functions of human intelligence. So there are 2 approaches in it. Social scientist approach is a holistic approach. Biological and computational scientist approach is a reductionist approach or a micro level approach. Now, there is always a conflict between these 2 approaches. Cognitive science is one science where this gap could be bridged by examining the biological, computational, and behavioral subsystem within the environment. So when we talk about cognitive science, we talk about biological science, we talk about computational science, and we talk about behavioral science, and within a given context or an environment. Therefore, cognitive science has become a much bigger role to understand human intelligence rather than only trying to understand the intelligence as a phenomenon with certain forms of capabilities that we can test under a psychological or a psychometric test. Now, those who would be interested in doing, therefore, cognitive sciences research, as I said, there is a concept of biological component, there is a engineering component, there is a behavioral component. In fact, those who are doing cognitive sciences research, they are doing either a clinical approach, they are doing such kind of studies either with a clinical approach or with an experimental approach. As I said, clinical approach is more like a test. If there is a brain damage, what kind of dysfunctions, psychological dysfunctions are taking place, so that we can tell that a particular dysfunction is related to a particular site in the brain or a site in the brain. So there is a clinical approach to understanding cognitive science, and there are experimental approaches as well. The experimental approach are basically brain sciences approach like signal processing, which is called electrophysiological approaches, EEG, or image processing like neuroimaging processes like functional MRI or positron emission tomography. Now in functional MRI, we can directly see how intelligence behavior takes place. Suppose you are trying to solve a mathematical problem, we can directly see in the computer how and which part of the brain is getting activated. What really happens, the moment you try to solve a problem, there is a neural fire. The moment there is a neural fire, the oxygen in that particular area is depleted. The moment the oxygen in that particular area is depleted, the nearby capillaries will open and blood flow will compensate for that depletion. The moment blood comes into that depleted area, we get two kinds of blood. One is oxygenated blood, one is deoxygenated blood. And the magnet actually captures the contrast between oxygenated blood and deoxygenated blood, which is called neuroimaging technique. There are two major techniques. One is called functional magnetic resonance imaging technique. Other is called positron emission tomography technique. It's called PET technique. Other than that, the EEG technique, electroencephalographic techniques we are aware of, and there are different kinds of electrical waves we can understand through a certain problem-solving behavior. There are behavioral approaches and there are computational approaches to study cognitive sciences. But when we study the brain sciences, the problem is in brain sciences is that the brain sciences try to understand through three models that how cognition takes place. One model is called localization model, one model is called lateralization model, one model is called regionalization model. The localization model says that a particular mental function is localized in a particular area. So if problem solving is localized in the frontal lobe, and if there is a damage in the frontal lobe, the person would not be able to solve problem. But we find that the relationship is not so simple, because the correlation between damage and impairment is never perfect. And for problem solving, we may not have one particular area. There may be several areas which are responsible for problem solving. And it's also possible that several mental functions are located in one particular area. I repeat, the localization theories that we understand through brain sciences in understanding intelligence need to be understood from this perspective, that the relationship between damage and impairment is never perfect, first of all. And second of all, the hypothesis that there is one-to-one relationship between a particular local area and a particular mental function is not correct. Because it is possible that there are several areas responsible for a mental function, or it's also possible several mental functions are actually located in particular areas. So we cannot get a one-to-one relationship to understand human intelligence through localization. The lateralization theory suggests slightly different. They said that we have got two sides of the brain, the left brain and the right brain, which are actually combined through certain fibers, which are called commissural fibers. They say the left of the brain is actually a dominant brain, and most of our analytical and problem-solving capabilities are actually located in the left side of the brain. And most of our holistic processing and parallel processing or simultaneous processing capabilities are located in the right side of the brain. Why do they say? Because they say the left side has got more concentration of the brain, the gray matter, the cells, the concentration of gray matter, the cells which actually process the information is more in the left side of the brain. And right side has got more white matter or fiber concentration. So the processing capabilities in the right side is much higher. So therefore, they say that the right side of the brain is more holistic at a macro level processing capability of intelligence, and left side is more at the analytical level of problem solving. But this theory is also doesn't hold good for all kinds of intellectual behavior because it's the indirect measure of brain function. We do not know actually whether there is interhemispheric transfer or not. And of course, there have been many attempts to actually measure. If you are aware of Roger Sperry's work, who actually dissected the two hemispheres and tried to understand independently the functions of the two sides of the brain, they find that several mental functions could actually be understood through lateralization theory, but not everything. Because brain function may not be very linear. I mean, they are non-linear. They are at times non-lateral as well. So there are differences in the cephalocaudal area as well. That is frontal lobe and the occipital lobe. They also process information differently. So frontal lobe consists of both left brain and right brain. The occipital lobe also has got left brain and right brain. So it is possible that left side and right side of the brain, frontal lobe and back side of the brain, they are also having differences in functioning level. So the lateralization theory doesn't also hold good so uniquely to understand human intelligence. And then come regionalization hypothesis. Regionalization hypothesis says they are actually based on brain imaging as well as signal processing like EEG. They say that the brain activation is actually depends on the network of certain neural activation. And that can be captured, as I just mentioned, through functional MRI or positron emission tomography. But as of now, we are not very sure when the brain is activated, what the brain is doing. Is it facilitating an activity or is it inhibiting an activity? The glucose metabolism in the brain, which takes place during an intelligent activity, what are the networks, how the networks have been formed, and what a particular area has been doing which is not activated. It's quite possible the area which is not activated may have a big role to play, but they are not critical in terms of expression. The expression takes place where there is a neural fire or there is a depletion of oxygen, where there is a discrepancy between oxygenated and deoxygenated blood. So the regionalization hypothesis also doesn't hold good all the time. So there are requirements of more and more cognitive science research in the brain sciences. Those who would be interested in doing researches in brain sciences through cognition, they must understand the localized areas do not function in isolation. There may be localized area of function like the Broca's area or the Wernicke's areas, which are responsible for our speech processing. That may be one odd case where the localization takes place so uniquely, but so many other mental functions may not be so localized. At the same time, the structure of the brain and the function mapping is not one-to-one. So there is no correlation between the structural architecture of the brain and the functional architecture of the brain. So we have a tendency to understand a direct relationship between structure and function. It's quite possible the functional architecture of the brain is different from the structural architecture of the brain. So more and more research are needed. And there are huge individual differences in cognition. Through test result, we find that no two individuals are different. So the question comes that how cognition becomes different, because the representations are different, because the transformation takes place at a different place, because the regional activation takes place at a different person at different level. Therefore, it's important to understand generality and individual difference together. So a psychometric approach and an experimental approach like functional MRI, both must join hand. And how do they understand cognition is altogether a different ballgame. Likewise, we do not know what happens in the resting brain. We know about the default network. The brain becomes most active when we are rested. But at that point of time, what the brain has been doing? We believe that when the brain is active, then only certain areas get activated. But actually, the resting brain is more activated than an active brain. So we still do not know actually what the resting brain has been doing when it is not in function. Likewise, we do not know how the brain functions. The brain plasticity is also not understood very well. So we need more and more brain sciences research to understand cognition in general and intelligence in particular. Now we should understand the computational paradigm. The computational paradigm suggests that human intelligent behavior can actually be digitized. We can understand intelligent agents in computational terms. There are two facets of it. One facet is a computational modeling, which is a mathematical modeling, and one is creation of intelligent machine, which is like a robo. So artificial intelligence, when it is incorporated in a robo, it becomes an intelligent machine. Now, computational modeling, which is part of human intelligence, what do they really do? They try to understand what are the different kinds of intelligent behavior we have. And within each behavior, what are the functional divisions? Like how sensation takes place, how perception comes up, how learning takes up, how memory comes up, how attention comes up. Let me tell you, for the benefit of all of you, at every second, we are actually bombarded with more than 60,000 input. But the brain actually processes around 40 to 45 input at 1 second at a particular time. How the other elements are eliminated, how certain particular stimuli are attended, then perceived, then we learn about it, we memorize it. I mean, these are the features which a computational model tries to understand. So if solving a mathematical problem is an intelligent behavior, the machine, the model tries to understand what are all different kinds of intelligent behavior, the varieties that we have to understand a general purpose cognitive architecture, and then how within each such behavior we can create a functional division so that we can actually come up with a particular intelligent machine which can recreate or replicate a human function. Now, the cognitive science in technology need to be understood. Why? Because when this effort has started coming up that we can model computationally intelligent behavior, we started finding out that technology is evolving faster than human capability. Because what really happens that today we all understand through artificial intelligence that the technology is moving faster than human capability. Now, if technology, technology is actually developing every day, but human capability doesn't develop every day. There is always a gap. And if the gap is widened, we can have two kinds of relationship between technology and cognition. We can have technology enabling cognition that we call human being can be considered as a system, or it may be cognition enabled technology, system as human. That is, as of now, what we find that if technology is assisting my cognition, ability to cognize, we'll call it as human as system. But there may be a time when robo takes place, the humanoids takes place of human being, then cognition enabled technologies will come into picture, then a system will become a human. So the first system we called as automation, the second system we call is autonomy. For the benefit of all of you, let me tell you that when technology enables cognition, it is called automation. And when cognition enables technology, it becomes autonomy. That is, suppose we can see everything at 180 degree. If I want to see something at 360 degree, we can use sensors or technology in order to see back and forth what is happening at my back as well. So I can reinforce my capability. I can read my capability with the help of technology. Suppose I can see up to 1 kilometer, but with the help of technology, I can see beyond 10 kilometers. Or we can restore human capability. That is, my capability has been retarded. I can, like magnetoencephalography is a magnetic hammer through which you can actually excite the human nerve system in order to optimize your capability. So when technology enables your cognition, it becomes automation. But it's also possible that the technology takes the place of human being. We call it cognition enabled technology, which is autonomy. That is, a human capability can be replaced by a completely a system. That is, a decision-making tool may come. If I can create a decision-making tool, then it will replace human decision-making. Therefore, or if I can develop a robot which can take care or function of a human being, we'll call it as autonomy. So the fundamentals of automation and autonomy is actually has emerged from computational modeling and the computational creation of a human intelligence system. Therefore, those who are interested in technology and cognition, they can engage themselves in understanding the research like automation and autonomy. But like in the brain sciences, we say that brain sciences cannot completely explain human intelligence. The technology or computational model or artificial intelligence also cannot explain human intelligence in full. In the next slide, I'll let you know about it. That is, there are cognitive challenges in system autonomy as well. Suppose a pilot is flying an aircraft. Everything is automatic. But the cognition here becomes a passive cognition. If the cognition becomes passive, there is a danger. Only automation will not take you forward. There are augmented cognition. At times it happens that there is a false sense of security in your augmented cognition and you start trusting on automation, but that also at times give you certain results which are not intended to. If you are making an error in an automated system, your error will never be known. It will completely be hidden. And also, those who believe that if there is an autonomous system, our workload will go down. Actually, our workload will go up. There will be uneven distribution rather than reduction of workload. So therefore, we must understand that the problem with system autonomy and technology and cognition also persists. Therefore, we must have a very composite understanding of brain sciences, technological sciences, and behavioral sciences. Finally, therefore, I tell you that if we do a SWOT analysis of cognitive sciences, thousands of research are being published. We have a very strong publication record. I mean, very wide variety of research reports are going on. A lot of multidisciplinary researches are happening. But the weakness is that the human intelligence has not been application oriented that much in behavioral sciences. Mostly those who are psychologists, they have been doing low risk, low gain type of effort. There is lack of transdisciplinarity. We are not joining hand with the brain scientist or neuroscientist as well as with the engineers. And as a result of which, what will happen? There would be a gap between human versus and artificial cognition. So human cognition and artificial cognition, if artificial cognition goes up every day, a day will come when in the human intelligence will be retarded or redundant. And also, because we have been emphasizing too much about artificial intelligence, our neglect for affective science will continue to happen. So we have been trying to sell artificial intelligence too much and neglecting human intelligence that way. So the opportunities is that we can create our curriculum differently. As of there in the book, we must understand what is happening all abroad. We must develop more and more research potentialities, and we must be able to utilize the available risk capital. A lot of those who are interested in doing research, DST, Department of Science and Technology, is a special program on cognitive science research initiative. Crores of rupees are being invested if you can develop a good cognitive science program or a human intelligence program. Along with other transdisciplinary sciences, there is every possibility that you get a very good project out of it. Thank you so much. This is what I wanted to convey.
Thank you so much, most respected Dr. Manis Mondal, for giving us a very detailed, insightful, eye-opening session on the intelligence. And it is beyond the words of appreciation, the way that you were very clearly narrating it. And of course, it is high time for the psychologists to join hands with the transdisciplinary approaches, because as you mentioned, as the concluding remark, as the technology is developing and growing and even outgrowing the possibilities of human intelligence, even though technology is the creation of humans, but then the greater possibilities of technological advancement can sometimes give a really a difficulty to the human cognition, and that it is high time that we all have to join hands in especially in developing the theories and practical applications of that. And here we have the National Institute of Advanced Studies, as well as Kristu Jayanti College Psychology Department, along with a lot of institutions around the Bangalore city and other states have joined for this national conference. So I now invite the delegates and participants to raise your questions and queries, and we can take a few of them at this time.
Yeah. Thank you.
Those who have questions, kindly raise your hand.
Since it is in a hybrid model, please, those who are asking questions may approach the microphone and please speak.
Morning, sir. How does the computational model help in terms of neural managerial decision making? Could you highlight?
Neuromanagement is altogether a different subject matter. As of now, we have been trying to understand why some people can take certain decisions which are so-called the best decisions. And the decision making, whether it has at all got any relationship with human intelligence or not, that we do not know. But there are people whom we have noticed that they can very clearly differentiate between best decision, good decision, and right decision. Best decision is a decision for which there is no alternative. Good decision is a decision there are alternatives, but you take one of these decisions. And right decision is a decision but the person understands that as of now, it may be a very self-defeating decision, but in long term, it will be beneficial. So when we take a managerial decision, then how the brain functions, does it function in the same way as it functions in other decision making? So when there is a top-down decision and when there is a bottom-up decision, the brain functions in different regional architecture. So in order to understand the regional architecture, we create such situations in the fMRI machines, the functional magnetic resonance machine. We try to understand how such regions take place, and then we do a path analysis. So it's a very complex process. As of now, I can tell you there is no clear answer for this. It's a evolving field. Management has also joined hand in transdisciplinarity. I mean, in fact, I have a book also on neuromarketing. Even marketing people have also come up with cognitive marketing, how the cognitive biases take shape. So, honestly speaking, a transdisciplinary research is very difficult to understand from a particular subjective point of view, but decision making is one area where cognition is very much interested, in particular in cognitive decision making, whether really the person can see future. Some people take decisions seeing the short-term benefit. Some people see the benefit which are intermediate term. Some people see it in a long-term manner. So which decision is the best decision, which is the good decision, and which one is the right decision? It depends on individual's experience, individual's knowledge, and individual's wisdom. So the complexity of the whole thing suggests that why psychological scientists must come into the forefront, which we are not today. My whole emphasis of telling here is that the psychological scientist is getting outclassed in understanding human intelligence. In fact, last year I attended the Science of Human Intelligence in a conference in IIT Jodhpur. They also have emphasized in the same line that we have been trying to augment artificial intelligence in a big way, but probably somewhere we have to stop and make sure that human intelligence still works. Because human intelligence works in not only in terms of their cognitive ability, in terms of their wisdom as well, in terms of their motivation as well, in terms of the emotional and affective phenomenon as well. That's why human brain is, or human intelligence is much more important than artificial intelligence.
Thank you, sir.
Thank you.
So there is a question in the chat box. In the last slide, sir, you have low risk and
low risk, low gain effort in
low gain. Yeah.
Low risk, low gain effort means we have been doing a small time projects. Look, because I was looking after the life sciences of DRDO, we had several institutes who are doing researches in cognitive sciences. And we found that undertaking a small project for the sake of doing a publication is actually a low risk, low gain type of research. When it has to be a high risk and high gain research, it must be we must be able to join in hand. That is, a program must be developed with projects coming from brain sciences, projects coming from artificial intelligence or computational sciences, and projects coming from behavioral sciences. Let it be a bigger project, and government is actually funding such projects. And as I said, I told you, the Cognitive Science Research Initiative, CSRI, if you see in the internet, it's a program under DST because I am one of the members in that funding organization. So I know how big it could be. It can be a crores worth of rupees project in doing fundamentals in cognitive science research, and also to understand the translational or the deliverable or the application oriented understanding of cognitive science or human intelligence kind of research. So my suggestion to all of you is that please go ahead with a high risk, high gain type of research. We may fail, but every failure will come up with certain forms of learning.
Good morning, sir.
Good morning.
My question is, like, in the beginning of the session, we established that intelligence was a subset of cognition. My question is about where does consciousness fall under all of this? Like in like neuroscience in general, where does consciousness fall into the picture?
We are only talking about cognition. Consciousness is a much bigger thing. I mean, then cognition is a subset of consciousness. It's only a subset of consciousness. And since you have raised this question, even today, some of the cognitive scientists have started asking this question, whether our brain hallucinates our consciousness or not. The kind of consciousness that we have, is it a hallucination of brain or actual consciousness? People have started asking even questions like that in terms of cognition. So if your question is very valid, consciousness is a much bigger thing. And then if you ask a human consciousness, consciousness is also a subset of a bigger form of awareness where there is unconsciousness, subconsciousness, unconsciousness. I mean, all kinds of consciousness phenomena are also there. So they are, this concept need to be understood in a bottom-up as well as in a top-down manner. Then only we will be able to locate it. Otherwise, if consciousness is a separate chapter and human intelligence is a separate chapter or cognition is a separate chapter, we'll never understand its location. So it's important that every chapter that we start reading or understanding, let us see it from a bottom-up as well as in a top-down fashion. So I hope I could answer your question.
Thank you, sir.
Good morning, sir.
Good morning.
So I have two questions for you.
Please.
Yeah. So the first one is, I know you are talking about bringing a transdisciplinary approaches. So how can our students get benefit out of it? Because most of the, engineers are working, taking the psychology subject.
Mhm.
So how can a student of psychology get into that arena?
Oh, well, I am teaching psychology in IIT only for last several years. So a lot of engineers have started understanding what psychology is. These are compulsory courses in engineering institutions. Almost all IIT, not almost all IIT, all IITs in 23 IIT. So I think we have a mental barricade that probably social scientists are different from the brain scientists. Actually, let us try to understand what are the kind of sciences we have. We have got natural sciences, we have got social sciences, we have got formal science. Under natural sciences, we have got physical sciences and life sciences. And then under social sciences, we have got psychological sciences, developmental sciences, economic sciences, social, political sciences, sociology. They are under social sciences. And under formal sciences is mathematics. Mathematics is the basis of doing all kinds of modeling for any kind of research. Like it can be a social sciences model, it can be a hard sciences model, physics model, or it can be a brain sciences model. For everything, we need a model, a mathematical model. We, the psychologist tool, use the tool of statistical model. Now, the question is, formal sciences provides us the model, social sciences and life sciences at least must come together. And then, of course, there is a possibility that engineering sciences, any tool that is being utilized, if you give me 1 minute, I'll tell you how the knowledge transpires here. Look, when a psychologist work, they think only in terms of, theoretical contribution. What theories are available? So when no knowledge to new knowledge comes up, it becomes a new theory. When theory to principles of application comes up, we try to understand the discovery of solution. When there is a discovery of solution, we try to understand the translational part. When there is a translational part of it, we try to develop the capability to produce. And then when we develop the capability to produce, we develop an end user integration. Now, these are the models of any science. Now, psychological sciences have generally, I found, they have got a divorce from clear medical sciences as well as engineering sciences. The whole effort that I wanted to make here is that human intelligence is a concept originated from psychological sciences, making best use by the medical scientists in order to understand how dementia takes place, how psychiatric illnesses take place. Even in normal functioning, how it takes place. And the engineers have started making tools, all kinds of tools, that how it can be integrated with human capability, that is human intelligence. The point here is that if engineering scientists, human sciences, brain sciences, they come together, then only it becomes a better transdisciplinary science. At an undergraduate, in the new education policy, the transdisciplinarity has been very heavily emphasized, that just don't restrict yourself to one domain. You have to move out from one domain to a second domain. So the transfer of knowledge from one domain to another domain will actually help us. Is there any other question?
Sir, there was one point being discussed during the last sessions of our conference. That is, nowadays, the difference between the technology and the human beings are getting lower. And like, Elon Musk is talking about implementing the chips into the brain. So do you think that our human brain will have the capacity to manage such a system which it has never witnessed in the course of evolution?
As of now, cochlear implantation is being done. The chips are being implemented, and there are researches going on whether internet chips can also be implanted in the brain or not. This is not today's research. Like last 10 years, people have been doing research on that whether chips could be actually inserted in the brain or not. The question is of the compatibility and the flexibility and the plasticity. Now, all these things are possible, but if the human brain has to understand better, human brain should also be understood through affective sciences as well. I think human brain has got a much bigger potentiality in terms of the emotion, the concept like emotion, motivation, connection, as compared to cognition. Cognition is important. I think human brain will continue to benefit from technology as a system. As I said, human as a system or system as a human, but the human emotions can never be digitized. That's for sure. If that cannot be digitized, the human plasticity of mind will retain its sanctity. That's what I believe. Of course, I do not know what will happen in deep future, but in near future, it is not possible because any kind of emotion or sentiment will create signal interference. The signal interference, a robot cannot have emotions. So in that sense, human brain is so important because it has evolved in several billions of years. An artificially created brain will only be created in the last several or couple of weeks or couple of decades. So anything that has evolved developmentally over 3 billion years has definitely got a bigger strength, better strength as compared to something which is just been created in last several decades. Therefore, we may make use of the technology to enhance the capacity of our brain, but that doesn't mean the brain becomes regarded or becomes redundant in the process.
So, could you please enlighten us on saying the researchers on cognitive neuroscience, how will it help the society in terms of detecting or improvising the situation with cognitive impairment among the elderly?
Well, the dementia research is one of the fast-growing researches, like Alzheimer's disease, Pick's disease, Huntington chorea, Parkinson's disease, Pick's disease. Everything is part of the dementia. Most of the dementia research today, the cognitive science research has reached to that level where the nano pump has been actually devised and placed in the brain to actually push in more blood in the demented area so that the dementia can be arrested. Just imagine the nano pump has been created in order to arrest the demented process, but the brain degeneration has taken place. So in brain sciences, actually cognitive neuroscience has done a huge stride. Not only in dementia, all kinds of diseases which are related to functional architecture of the brain has come up in a big way. So cognitive neuroscience is a subject matter I would certainly request some of you can take it up in your future endeavor.
Do we have any more questions?
Good morning, sir. My question is, how will technological singularity impact the field of psychology in the upcoming years?
Technological
Singularity.
similarity, I think this is a problem of mind versus mindset. There are a lot of similarities. I think technology is also a science, psychological science is also a science. Instead of trying to develop a parallel or comparability and compatibility between these two, try to understand the complementarity between these two. Well, we have a tendency to compare between two sciences or to see how they are compatible to each other. Your question is on compatibility. I say it's on complementarity. That is, the strength in psychological science is weakness in engineering sciences, and the strength in engineering sciences is the weakness in psychological sciences. So let us try to understand two sciences in terms of complementarity rather than compatibility or comparability. Then probably we'll come up with a better science. And this possibility is there in new education policy. Please go ahead with this. Today, let me tell you, last year I was teaching in University of Pennsylvania. The people who have done their degree in history is studying medical sciences. The undergrad program they have done in history and philosophy of mind. Today, they can actually ultimately graduate and do PhD in medical sciences or engineering sciences. So that opportunity is now being given. Let us make full benefit of it. At least at the research level, nobody is stopping me. Well, I was a pure psychologist, but so many engineers were working with me and my medical practitioner in DRDO. You must have heard the name of Defense R&D organization. It's a huge organization. It's 8,000 engineers and scientists. But I was working there as a director general, as a psychologist. I'm a psychologist.
I now invite Ms. Amriti, first year clinical psychology, to express our gratitude through the vote of thanks to sir.
Appreciation is a wonderful thing. It makes what is excellent in others belong to us as well. As we express our gratitude,
Yes, go ahead. We are able to hear you. Please go ahead.
As we express our gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. I would like to extend my thanks to each and every one of you for gracing us with your presence today at the National Conference on Intelligence in Animals, Humans, and Machines. It is my privilege to have been given the opportunity to deliver the vote of thanks on behalf of the organizing committee. Firstly, I would like to express our gratitude to Dr. Manis Kumar Mondal. Your insights have been truly enriching and have left our minds thinking. Thank you, sir, for sharing your knowledge with us today. We are extremely grateful.
Thank you. Thank you so much.
We discussed the topic human intelligence, behavior, neuroscientific, and computational approaches. It helped us to understand the relevance of artificial intelligence and understanding intelligence. And we also saw the intelligence, a subset of cognition that was sensation, perception, attention, memory, learning, problem solving, and emotion. We discussed the paradigms of to understand intelligence, psychometric approach, cognitive psychology, brain sciences, and artificial intelligence. A science that investigates the representation of and processing of information was cognitive science. And sir also highlighted how technology is evolving faster than human cognitive capability. He helped us to also expand our knowledge and opportunities in innovative curriculum and research potentialities this field has. Thank you so much, sir, once again.
Thank you. Thank you so much. Thank you.
Secondly,
thank you, everybody.
Secondly, I thank Father Emmanuel PJ for moderating this insightful session. Thank you, Father, for taking our time and joining with us today. I would like to thank the teacher coordinators, Ms. Shamili Chatterjee and Ms. Priyanka Vyar for their support and guidance throughout the process. Thank you, ma'am. I would like to acknowledge the hard work and dedication of the organizing committee who have put in countless hours of effort to ensure that this event was a success. Your tireless efforts have certainly paid off, and we are all grateful for your dedication. I extend my gratitude to the stage team and the tech team for aiding us. This hybrid session wouldn't have been this smooth without your help. Last but not least, I would like to thank each and every one of you for joining us here today. Your presence has made this event even more special. Once again, thank you all for being part of this enriching session. Have a great day ahead.
Thank you. Thank you, everybody.
So thank you so much, sir, Manas sir, for enlightening our students. And we once again request you, when time permits, please visit Kristu Jayanti College. We have 10,300 students in this autonomous college. So we will be honored to have you here. And we have around 1,200 students studying psychology in undergraduate and postgraduate together. So that we have a larger body of students in psychology. Please give us
I'll make it, surely, sir. I'll make it, and I'll make it a point that the moment I come to NIMANS actually because I'm a member of the selection committee there, and of course to NIAS. And of course, we have several DRDO labs in Bangalore. So next time when I visit, I'll definitely inform you, and I'll take a chance to actually come and visit students as well.
Awesome. Thank you. Thank you so much. Thank you.
Thank you, everybody. Thank you so much.
Thank you.
Thank you.